H3. Introduction to the Solar System. P. Start by introducing the Solar System as a huge system centered around the Sun. It contains the Sun, 8 planets, dwarf planets, moons, asteroids, comets, and other objects. The main purpose of the 3D project is to help viewers understand the enormous distances between planets. In normal pictures of the solar system, planets are often placed close together so they can all fit on the screen. This can give a misleading impression of how far apart they really are. P. 3D idea. Begin with the Sun in the center and gradually reveal the planets around it. HRR. The Sun as the starting point. The Sun should be the main reference point because planetary distances are usually measured from the Sun. The average distances of the planets from the Sun are approximately P. Mercury 0.39 AU, Venus 0.72 AU, Earth 0.1 AU, Mars approximately 1.52 AU, Jupiter 5.20 AU, Saturn 9.58 AU, Uranus 19.2 AU, Neptune 30.1 AU. AU, or astronomical unit, is the average distance from Earth to the Sun, about 149.6 million kilometers. Inner planets, Mercury to Mars. The first 4 planets, Mercury, Venus, Earth, and Mars, are called the inner planets, or terrestrial planets. They are relatively close to the Sun compared with the outer planets. However, even these planets are separated by millions of kilometers. For example, Earth is about 150 million kilometers from the Sun, while Mars is about 228 million kilometers away. 3D idea. Slowly move the camera outward from the Sun and show Mercury, Venus, Earth, and Mars appearing at their correct relative distances. Add labels showing their AU and kilometer distances. The asteroid belt. After Mars comes the asteroid belt, located roughly between Mars and Jupiter. The asteroid belt contains many rocky objects, but it is not a solid wall of rocks. There are enormous spaces between individual asteroids. This part of the model is important because it shows the transition from the relatively compact inner solar system to the much more widely spaced outer solar system. 3D idea. Create a broad ring containing numerous small asteroids. Keep the asteroids widely separated rather than making the belt look like a dense wall. Outer planets, Jupiter to Neptune. The distances become dramatically larger after Mars. Jupiter is about 5.2 AU from the Sun, while Neptune is about 30.1 AU away. This means Neptune's average distance from the Sun is roughly 30 times Earth's distance from the Sun. The outer planets are Jupiter 5.20 AU, Saturn 9.58 AU, Uranus 19.2 AU, and Neptune 30.1 AU. The gaps between these planets are much greater than the gaps between the inner planets. As the camera moves outward, increase the distance between planets dramatically. This makes the scale difference visually obvious. This is one of the most important parts of the project. A normal solar system illustration usually cannot show both planet sizes and distances at the same scale. If you make the planets large enough to see, the distances would have to be enormous. For example, if Earth were represented by a small sphere, Neptune would still need to be placed extremely far away to maintain the correct distance ratio. Use a 3D grid or measurement markers to communicate the scale. Add floating distance labels. Sun to Earth is 1 AU, about 149.6 million kilometers. Sun to Jupiter is 5.2 AU, about 778.5 million kilometers. And Sun to Neptune is 30.1 AU, about 4.50 billion kilometers. This makes the abstract numbers much easier to understand. Now directly compare the planets. Earth is only 1 AU from the Sun, but Neptune is about 30 AU away. So, in terms of average orbital distance, Neptune is about 30 times farther from the Sun than Earth. You can also demonstrate how much space exists between the planets. For example, the distance from Earth's orbit to Jupiter's orbit is several AU. The distance from Jupiter's orbit to Saturn's orbit is also several AU. 3D idea. Use an animation where the camera starts at Earth and travels outward toward Neptune. Display a distance counter that increases as the camera moves. Final 3D overview. Finish by zooming the camera far away from the Sun so that the entire planetary system can be seen. At first, the inner planets may appear relatively close together. As you zoom out, Jupiter, Saturn, Uranus, and Neptune appear much farther apart. The final message should be that the solar system is much larger and emptier than typical illustrations suggest. The planets occupy only tiny regions compared with the enormous spaces between their orbits. 3D idea. End with all 8 planets labeled, their orbital distances shown, and a final statement such as, "The farther we travel from the Sun, the greater the distances between the planets become." This structure would work well for a 3D animation, Blender project, educational video, or presentation.